This is C Lanston Davis and I'm here to just give you a small presentation on the topic of protocols. So let's get started right away. First we have what are protocols and why are they needed, and what kind of protocols am I going to discuss today. So protocols are basically a set of rules that are established for the proper governance of a particular activity or an organization or any component or any kind of sport or as such. But what am I going to discuss today? We are going to discuss today about networking protocols. So let me make it more clear. And what are protocols? Networking protocols. They're an established set of rules that determine how data is transmitted between different devices in the same network. That is basically they govern all types of communication between the same network. And now to make it more clear, I've taken a few examples, real life examples on why these networking protocols are essential in our day-to-day life. For networking. So now in this example we see a British man and a Chinese man. So this British guy speaks English only. Let's assume he speaks English only and not Chinese, and this Chinese guy speaks Chinese, not English. So what if the British guy speaks in English to the Chinese guy? What happens? This Chinese guy would not be able to comprehend or understand what this guy is trying to say. Is the communication valid and understandable and proper? No, it is not. It's a useless communication. Similarly, we have in this side a rapper and this side a small kid. The rapper is used to speaking fast words which the small kid is not able to understand, would not be able to understand. So is this communication valid? Is the message what the rapper is trying to say reaching the listener even though they are speaking the same language? No, it's not possible. So basically use of time. And why am I choosing, like what kind of resolution is it there to solve all these kinds of problem in the networking chapter? So that protocol I have chosen is the TCP Protocol, or the Transmission Control Protocol. Okay, the Transmission Control Protocol. And let's discuss this in a little more detailed manner. So about a protocol, there are an essential set of characteristics that are needed to be abided, or the regulations or elements that define a protocol. So let's get started with it right away. First we have message encoding. What is message encoding basically? A message encoding refers to a kind of encoding operation, but let me discuss it in a little more detailed manner. So first, in message encoding, why is it essential in a protocol? So about message encoding, the problem is that there isn't just one kind of transmission medium for the transmission of data. Like we have two basic transmission mediums. One is wired and one is wireless. So depending on what type of transmission medium you're going to send data, the type of encoding is essential. Okay, first we have data, then it's sent to the encoder, then to the transmitter, then to the through the medium, then to the receiver, then to the decoder, and then to the receiver. The receiver in sense the listener, the other side of the computer, who is listening to what data we are speaking or the data we have transmitted. So depending on the type of transmission medium, if it is wired, we have to send data in types of signals, or if it is wireless, we have to send data in the form of waves. So it may differ. Hence, message encoding is essential in the part of a protocol. And next we have message formatting and encapsulation. From who to whom we are sending data, that is essential, and that we need to know. For example, the person who has received data needs to know from who it is sent so that he could send back the data. Hence, we need to type in our addresses, or we need to send in our computer addresses through that header file or that packet that is sent from our computer to the next computer. Okay, so hence we need to format the message or encapsulate with the essential addresses that is required. That is the sender and receiver header format. And next important element is the message size. For example, you have a big data, a 2 GB data, and you need to send it from one person to the other person, that's from you to your friend. How are you going to send it? Basically, we just select send, but it isn't that kind of simple operation. That 2 GB data is split into packets, and each packet is sent one by one. So in order, why are we doing this? Why are we breaking down the packets? Because we have a transmission link, that's wired or wireless medium. We have transmission link, and there is a regulation or a higher value, or what do they call it? The we call it the threshold. We call it the threshold, a threshold to which the message size can be sent or packet can be sent. So that threshold would happen to be very less when compared to the data we are sending. So in order to fulfill the threshold, we break down the big packet into smaller packets so that the transmission of data would be very much easier. Hence, it is also an important element in defining a common protocol. And next we have message timing. We saw in a real life example about the rapper and the quiet kid. Okay, so basically the rapper needs to slow down his tone or his voice or the message he's speaking in order so that the quiet could be able to listen. Hence, there is something in the networking details, that is the flow control, that speed slows down the data. What am I going to tell is that there we have a sender from one computer and the receiver in the other computer. And if the sender happens to be the latest version of a computer that can send data in a lot of bytes per second, but we have the receiver which is a Windows 7 or less. So what are we going to do? Will the data that is transmitted from the higher end computer to the lower end computer would be transmitted fully? No, we would cause problems such as congestion control or many such, which would result in not the proper receiving of data in the receiving computer. Hence, we follow the concept of flow content response timeout, which slows down or regulates the message that is being sent from the transmitter so that the data would be perceivable by the receiver. And for the last element, we have message delivery options. We need to, as said earlier, we need to send the address of a person that is encapsulating the message within the packet, so that we would be able to know who we are sending the message, or the person would be able to understand from who the message is being sent. But what if you're not gonna only send the message to one person, but 3 people or 4 people or the people all around the globe? So we have a message delivery option such as unicast, that is the message is sent to only one person, or multicast, more than one person but not the entire world, and broadcast, sent to the entire world. So we need to specify all these elements, or these are essential elements that define the protocol of how it's being sent. Okay. And for better understanding, let's compare UDP and TCP, the user datagram protocol versus the TCP. So I believe by comparison we'll be able to understand more stuff. So let's discuss this in further detail. And what is the major difference between UDP and the TCP? The UDP has a packet size of 8 bytes while the TCP has a packet size of 20 bytes. This is a great big difference in defining the difference in protocols between the UDP and the TCP. By how? Let's look it out. We have packet arrival, reorder of packets, congestion control, a basic set of comparing factors. And first we have packet arrival. If the packet is sent from the sender to the receiver, will the packet be arriving safely at the receiver in UDP? Well, the answer is no. Why? The packet arrival, we have, as said earlier, 8 bytes only for UDP. So if there is a problem in the transmission link, or any kind of problem between the transmission time or due to traffic or any kind of such, if the packet is not arrived at the UDP, the receiver would not be able to tell whether the packet has arrived or not to the TCP. Now the question is why? Once again, I'm telling 8 bytes of data. 8 bytes of data only per packet size. This 8 bytes of data would not contain any kind of connection, or UDP is called the lightweight connectionless protocol. Okay, remember, the UDP is called the lightweight connectionless protocol. There is no established set of connection before the transmission of packet. Okay, there is no established set of connection before the transmission of packet. Hence, before the connection is set, there's no connection, right? So before the connection is set, if the packet is sent also, the receiver would not know whether a packet is coming or not. It would not be able to send an acknowledgement to the transmitter that the packet that I have received is not being sent, or the transmitter would not be able to know that because of the no connection, they just send the packet without any further acknowledgements. So the packet arrival is very much not guaranteed. Reordering of packets. The As said earlier, 8 bytes of data. Those 8 bytes of data would not contain any kind of addresses of the sender or the transmitter or the receiver. Without addresses, there is no identity of that packet to whom or to who, except the last address. Only one address, the last address, except when it's sent. Okay, so there's no reordering of packets. And next we have congestion control. Congestion control basically refers to the traffic problems that arise due to traffic or the network traffic. At congestion control, packets may get lost more often, and there is no guarantee that packets may be received at the receiver, and there is no guarantee the packets may be resent from the transmitter. Once again, due to the packet arrival option, which we discussed much more in detail. And about TCP, comparing it with TCP, and I said earlier, TCP has a 20-bit byte packet size. This packet size would contain all the address data and as such, but most importantly, TCP is called the reliable connection oriented network protocol. Okay, connection oriented protocol. Why? And we have here delivery acknowledgements. The delivery acknowledgements process are sent properly because are received properly because we have already set a connection between the sender and the receiver. And we have retransmission. If a packet is not sent, packets are retransmitted. In order delivery, due to the numbering or the serial ordering of data, because and due to the connection and due to the large packet size, where every detail of that packet is mentioned properly, in order delivery is very much possible. Congestion control, even if a packet is lost, we have the TCP. It would resend the packet. As said earlier, retransmission and error detection. If there is an error, okay, and this is a very important point. In UDP, we have 16-bit checksum, and in TCP also we have a 16-bit checksum. But in UDP, the 16-bit checksum error process is not mandatory except for a IPv6 version. Okay, so except for that, error detection or the checksum method is not mandatory at all. But TCP, it is mandatory whether it's an IPv4 version or an IPv6 version. Hence, error detection plays a vital role in performing that the data sent from the transmitter is equal to the data received by the receiver or not. Okay, so let's discuss. Our topic was TCP, and let's discuss is in a more technical oriented way. So how does this TCP protocol originate? As said earlier, the most important process in this TCP is that connection, a reliable connection oriented protocol. Okay, so how does this connection be established to make it modal? And that's why we have a three-way handshake. A three-way handshake is referred to three steps between the desktop and or we have the sender and the receiver. In this case, we take the sender as the desktop and the receiver as the server. Okay, the first step, what the sender does is it sends an acknowledgement. In the three-way handshake, the first handshake is that the desktop sends an acknowledgement to the server to check whether the server for connections. And in the second step, if the server receives the packet or receives the acknowledgement, not the packet, let's say acknowledgement, then it sends a sync acknowledgement back to the desktop saying, okay, I've got the packet. And then in the third step, we have the desktop saying, okay, then let me send data. So basically, it's asking a person to go out on a date. The first thing you ask the other person, let's go on, can we go out on a date? And the second person thinks that, okay, whether or not, okay, is the connection free or not? In the networking concept, in the networking basis, the server checks whether all of its connections are free or not. As in the date concept, in the real life concept, the person thinks whether he or she should accept the date or not. And if it's okay, that's the sync acknowledgement that is sent from the server to the desktop. And now the desktop thinks, okay, the desktop, the date receives or says back, okay, then let's go. Okay, so that's the third acknowledgement sent by the desktop to the server saying, okay, now let's communicate. So this seems a little too big, a vague concept, correct? To understand more, let me dig in a little more deeper. So step 1, what the desktop sends, that it sends a sequence with its sequential number of communication. It sends to the server the sequential number, that is the computers, that's the senders, the sequential number 9001, and with its acknowledgement as 0, because this is the first handshake. The second step is that the sync acknowledgement is sent from the server to the desktop with a sequential number of its own sequential number. I have described the sequential number as 5001, but in real life sequential numbers can be very large. And the acknowledgement number is basically 1 plus. Remember, the acknowledgement number sent from the server, that is the second handshake sent from the server to the desktop, is 1 plus the sequential number of the first transmission. This is issued in order for a proper reliable connection. Okay, so not just any number, but 1 plus the sequential number of the first handshake. That's the acknowledgement. And the step 3, we have the connection set from the desktop back to the server, saying sending its own sequential number and its acknowledgement. There once again the acknowledgement is, I have given it as 5002. Remember, this acknowledgement is 1 plus the sequential number of the previous handshake, that is the second handshake. This is the third handshake what we are talking about. 1 plus the acknowledgement of the previous sequential number of the previous handshake, that's the second handshake. Okay, so 1 plus 5001 happens to be 5002, which is the acknowledgement sent by the desktop to the server, that in the third handshake. And the sequential number, remember, the sequential number is 9002 in the third handshake. It is not because the acknowledgement from the received from the second handshake is 9002, but it is 1 plus the sequential number of the first transmission, the first handshake sent from the sender to the receiver, that is 9001 from the sequential number of the first handshake plus 1, that is 9002. Okay, so I guess these steps are clear. And yeah, so now let's discuss which is better, TCP or UDP. It all depends upon the application. Okay, and nothing is wasted when invented. And now we have text communication. Okay, examples make the understanding much more better. So first we have text communication. Which is better, TCP or UDP? Well, the answer is TCP rules. Why? Because what if you're going to send a mail from one person to another, from you to your friend? And I said earlier, ordering of packets is not done properly by the UDP. So if you're going to say, hi, I am Jesus, or hi, I am Arul. Okay, hi, I am Arul. And when it is received by the receiver, it would say Arul, hi, am I. The number of words would not be lost also. In case you're saying hi, I am Arul, you would get only Arul, I am. Okay, you would miss the hi. So that's how UDP works. I said earlier, please refer to the back of the video where I have explained it once again, so you would understand a little bit more. So for preventing the reordering of packets, to prevent the loss of packets, we need TCP in case of mail transmissions or any kind of text communications. Well, now let's take this look in another perspective. We have multimedia streaming. Which is better, TCP or UDP? Okay, think about it. Which is better, TCP or UDP? Well, the answer is UDP. Why do I say so? Okay, some people prefer UDP and some people prefer TCP. But in our present world, most people prefer UDP. Why is it so? Why? Because less overhead. 20 bytes per packet is too much large for a video call or the broadband connection establishing problems. Okay, and the send delay is understood, and the data is less consumed basically. Okay, that's why people prefer UDP. To explain this in a little more easier way, for example, I'm conducting a video call with you, and would I prefer a real life talk or a fake talk? Why do I mean by fake talk? Like for example, transmission protocol is, as I said, TCP would result in the retransmission of packets. So what if I'm talking over here and a part of the packet gets lost? Just or 1 second, just 1 second of a packet size of data gets lost, what happens is that it would interfere in the further conversation. That 1 second would not be a great problem to us because we talk freely and as such, but that one packet will interfere with all of further communications and put it as a drag between real time talk. It would not seem like a real time talk, and it would be very much disturbed. And mostly that's why people prefer UDP to TCP. Of course, I want that 1 second talk in my network, but it not make much difference if it gets lost also. That's all. That's what I think, because UDP does not make further complications. I mean, TCP UDP does not make further complications. Small problems would always occur. Well, I want my conversation to be real, and that's why I prefer UDP to TCP. Well, in some cases people prefer TCP to UDP in case of multimedia streaming. Why I say is that if that person has a greater width of bandwidth, he would have no problems in these kind of calls and such. And also and in most cases in nowadays, some firewalls block UDP transmissions for the security reasons and such. Hence people prefer sometimes TCP towards UDP. I hope you understand this. And in this case, obviously UDP rules at majority. So thank you for watching this video till the end, and I guess you would have understood a lot of these details much more in detail. So I guess that's all. Thank you so much for understanding, and any doubts, please let me know. Thank you. Bye.